Neutron stars may contain one of the most dangerous substances in the universe. Okay, let me back up a bit. Firstly, let's discuss neutron stars and what makes them different from other stars and other celestial bodies.
When a very large star dies and collapses in on itself in a supernova, all of the subatomic particles in the center of the star are squeezed together violently with extreme force. As the star is collapsing, these particles push against gravity, and one of two things occurs as a result. If the force of the collapse is stronger than the force of the particles, a black hole will form. If the force of the particles is stronger, a neutron star.
This itself isn't really what makes neutron stars so different, however. What does is their core. You see, neutron stars are dense, like really dense, and their insides are actually more similar to the universe shortly after the Big Bang. Because of this different environment, the cores of neutron stars are actually made up of the building blocks of the subatomic particles from earlier. Quarks. Quarks are the building blocks of protons and neutrons, but there are some key differences. The main one being that they do not like to be alone. Quarks are what are called confined particles, meaning that they are always connected to one another. They've only ever been observed in groups of 2 or 3.
There are 6 types of quarks, but only 2 have ever been shown to create stable matter: up and down quarks. These are the quarks that are found in protons and neutrons, and all of the quarks quickly decay into other quarks until resolving to up and down quarks. But inside neutron stars, this changes.
Many believe that within neutron stars, quarks may go through what is called deconfinement, where they lose their bonds with one another and create quark matter, matter made entirely of quarks. And if the pressure and density within a neutron star is great enough, these quarks may form a whole new type of substance. Earlier I mentioned how neutron stars may contain one of the most dangerous substances in the universe, and now we can finally discuss that. You see, because of the intense environment within neutron stars, some theorize that the deconfinement of up and down quarks, as well as the density imposed upon them, may result in the stability of other types of quarks, specifically strange quarks. Strange quarks are complex, hence the name, but they are the building blocks of what could be the most ideal substance in the universe: strange matter.
Strange matter is a type of quark matter made almost entirely of strange quarks. It is indestructible, dense, and perfectly stable. However, this perfection has one problem tied to it. When normal matter contacts strange matter, its perfection and stability may motivate the up and down quarks to turn into strange quarks, turning the normal matter into strange matter.
So that's the most dangerous substance I've been mentioning, but how does that affect us, you might be asking?
Neutron stars will occasionally bump into each other, or with black holes, and create a kilonova, a stellar collision where neutron stars erupt and send their insides flying. This could cause strange matter particles to soar through space for millions upon millions of years. If one were to collide with the sun or Earth, the star or planet would almost, if not immediately, turn into strange matter and would shrink immensely as its density increased.
This is very unlikely, as some theorize that these strange matter particles, or strangelets, have actually been soaring through space since the start of the Big Bang. However, even though it is unlikely that Earth will be consumed by a strange foreign substance, it is still important to understand what is out there in the vast emptiness of space, and to be prepared for whatever scientific discoveries humanity may have. And who knows, what we now dub as the most dangerous thing in the universe may very well, in the future, be what allows us to understand how our universe began, is growing, and will evolve in the future.